There is no specific code requirement mandating the installation of an expansion joint in a horizontal run of 2-inch polyvinyl chloride or PVC conduit beneath a mobile home, irrespective of the conduit's length. To elaborate further, the National Electrical Code, or NEC, serves as the primary standard governing electrical installations. It outlines requirements for various aspects of electrical systems, including conduit installation. However, the NEC does not stipulate a minimum length of PVC conduit that necessitates an expansion joint in the described scenario. Expansion joints are typically employed to accommodate thermal expansion and contraction of conduit materials. PVC, in particular, exhibits a relatively high coefficient of thermal expansion compared to other conduit materials like metal. This means that PVC conduit can expand and contract significantly with temperature fluctuations. In installations where long runs of PVC conduit are exposed to varying temperatures, expansion joints are crucial to prevent stress and potential damage to the conduit system. These joints allow the conduit to move freely without exerting undue force on connections or supports. However, the absence of a specific length requirement in the NEC for expansion joints in horizontal PVC conduit runs under mobile homes suggests that the need for such joints is dependent on other factors. These factors may include the expected temperature variations, the method of conduit support, and the overall design of the electrical system. Local codes and regulations may also impose additional requirements or recommendations regarding expansion joints. Therefore, it is essential to consult with local electrical inspectors or authorities to ensure compliance with all applicable codes. When determining whether to install expansion joints, consider the following points. Firstly, assess the temperature range to which the conduit will be exposed. If the conduit is likely to experience significant temperature fluctuations, expansion joints may be beneficial. Secondly, evaluate the method of conduit support. Properly supported conduit can better withstand thermal expansion and contraction without stressing connections or supports. Thirdly, consider the overall design of the electrical system. The layout of the conduit run and the presence of any bends or offsets can influence the need for expansion joints. While the NEC does not mandate expansion joints for all horizontal PVC conduit runs under mobile homes, it is crucial to exercise good engineering judgment and consider the specific circumstances of the installation. Installing expansion joints may be prudent in situations where significant temperature variations are anticipated or where the conduit run is particularly long or complex. The NEC provides guidelines for the selection and installation of expansion joints. These guidelines address factors such as the expansion coefficient of PVC, the expected temperature range, and the allowable movement of the joint. Adhering to these guidelines ensures that the expansion joint is properly sized and installed to effectively accommodate thermal expansion and contraction. In addition to expansion joints, other methods can be employed to mitigate the effects of thermal expansion and contraction in PVC conduit systems. These methods include using expansion couplings, which provide a degree of flexibility in the conduit run, and installing the conduit in a manner that allows for some movement. Expansion couplings are similar to expansion joints but are typically used in shorter runs or in situations where the expected movement is less significant. Installing conduit in a manner that allows for some movement involves providing adequate space in between supports and avoiding rigid connections that could restrict expansion and contraction. It is also important to consider the potential for condensation within the conduit. Condensation can occur when warm, moist air enters the conduit and cools, causing water to condense on the inside of the pipe. This condensation can lead to corrosion and other problems. To prevent condensation, it is important to seal the ends of the conduit and provide adequate ventilation. Sealing the ends of the conduit prevents moist air from entering the pipe. Providing adequate ventilation allows any condensation that does form to evaporate. In summary, while there is no explicit NEC requirement for expansion joints in all horizontal runs of 2-inch PVC conduit under mobile homes, it is essential to consider the potential for thermal expansion and contraction and implement appropriate measures to mitigate its effects. These measures may include installing expansion joints, using expansion couplings, providing adequate conduit support, and preventing condensation. Always consult with local electrical inspectors or authorities to ensure compliance with all applicable codes and regulations. Furthermore, the selection and installation of PVC conduit should adhere to industry best practices and manufacturers' recommendations. This includes using appropriate fittings and supports, properly preparing conduit surfaces, and ensuring that all connections are secure and watertight. The NEC addresses various aspects of PVC conduit installation, including requirements for conduit fill, support spacing, and protection from physical damage. Conduit fill refers to the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by conductors. Exceeding the conduit fill limits can lead to overheating and insulation damage. The NEC specifies maximum conduit fill percentages for different types of conduit and conductor combinations. Support spacing refers to the distance between conduit supports. Properly supported conduit is essential to prevent sagging, bending, and other forms of damage. The NEC specifies maximum support spacing for different types of conduit and installation methods. Protection from physical damage is crucial to ensure the long-term reliability of the conduit system. The NEC requires that conduit be protected from physical damage in locations where it is likely to be exposed to impact, abrasion, or other hazards. This protection may involve using rigid conduit, installing the conduit in a protected location, or providing additional shielding. In addition to the NEC, other standards and guidelines may be relevant to PVC conduit installation. These include standards from organizations such as the American Society for Testing and Materials, or ASTM, and the National Electrical Manufacturers Association, or NEMA. ASTM standards specify the physical and mechanical properties of PVC conduit materials. NEMA standards provide guidelines for the proper selection and installation of electrical equipment, including conduit. Adhering to these standards and guidelines ensures that the PVC conduit system is installed in a safe and reliable manner. It is also important to consider the environmental conditions to which the conduit will be exposed. PVC conduit is resistant to many chemicals and corrosive substances, but it can be damaged by certain materials. Consult with the conduit manufacturer to determine the suitability of PVC conduit for specific environmental conditions. When installing PVC conduit outdoors, it is important to protect it from direct sunlight. Prolonged exposure to sunlight can cause PVC to become brittle and degrade over time. This protection may involve painting the conduit with a UV-resistant paint or installing it in a shaded location. In addition to the technical aspects of PVC conduit installation, it is also important to consider safety precautions. Always to energize electrical circuits before working on conduit systems. Wear appropriate personal protective equipment such as safety glasses and gloves. Follow all applicable safety regulations and guidelines. Working with electricity can be dangerous, and it is essential to take precautions to prevent accidents. When cutting PVC conduit, use a sharp saw or cutting tool to create a clean, square cut. Sever the cut ends of the conduit to remove any sharp edges or burrs. These sharp edges can damage conductor insulation and make it difficult to pull conductors through the conduit. Use a conduit bender to create bends in PVC conduit. Avoid using excessive force or heat, as this can damage the conduit. The use of heat may violate the listing of the product. When joining sections of PVC conduit, use PVC cement to create a watertight seal. Follow the manufacturer's instructions for applying PVC cement. Ensure that the surfaces to be joined are clean and dry. Allow the cement to cure completely before applying pressure to the joint. When pulling conductors through PVC conduit, use a wire pulling lubricant to reduce friction. This will make it easier to pull the conductors and prevent damage to the insulation. Avoid using excessive force, as this can damage the conductors or the conduit. After installing the conduit system, inspect it thoroughly to ensure that all connections are secure and that the conduit is properly supported. Verify that the conduit is protected from physical damage and that there are no sharp edges or burrs that could damage conductors. Before energizing the electrical circuits, test the insulation resistance of the conductors to ensure that there are no shorts or grounds. Use a megometer to measure the insulation resistance. A low insulation resistance reading indicates a problem with the insulation. In summary, the installation of PVC conduit requires careful planning, attention to detail, and adherence to applicable codes and regulations. By following these guidelines, you can ensure that the PVC conduit system is installed in a safe, reliable, and compliant manner. Always consult with qualified electrical professionals for assistance with complex or unfamiliar installations. Consider the effects of direct sunlight and chemicals on the PVC, and always observe appropriate electrical safety measures.